Hi all, I'm Madam Kong. Welcome to my virtual class. The purpose of this video is to revise Organic Chemistry SK025 by using set PSPM 2015-2016. So let's start. This is the original question. So 2-methylbutane react with bromine in the presence of UV light to give monobrominated product. So you must know how to draw 2-methylbutane. So this is a structure 2-methylbutane. Draw the structure of the major product form. So for this reaction means the bromine can be substituted over here. This one is primary. This one also primary. For this carbon, this is tertiary. For this one, it is secondary, and then this one is primary carbon. So compare the most stable class of carbon is over here. That's why the bromine will be substituted here. So this is the answer. Near type of reaction, so free radical substitution, and then next, give the reaction mechanism for A1. So make sure you give the major product, and then your mechanism must with the major product. So step 1 is change initiation step. So homolytic cleavage of bromine molecule to form free radical. Okay, the UV is provided because you need to provide the energy in order for the homolytic cleavage to happen. Okay, step 2, there are 2 equations, change propagation step. So bromine free radicals collide with the for the CH bond and the methyl free radical form. So methyl free radical react with the bromine molecule. Okay, here the methyl free radical react with the bromine free radical and regenerate the chlorine, the bromine free radical. The last step is the reaction stop when 2 free radicals collide and combine with others. So there are 3 possibilities for the change termination step. Reaction of 2-ethyl 1-pentane with several reagents are shown below. So 2-ethyl 1-pentane is an alkene. So the reaction for the product for B is undergo electrophilic addition. 2 hydrogen atom is added. So here it becomes CH3CH. CH3CH. Okay, for this one, H and Br, H will be added to this C and then Br will be added to this C. Why? Because it's according to Markovnikov rules. In an electrophilic addition, the more positive reagent, in this case is hydrogen, is added to the carbon-carbon double bond that has greater number of hydrogen atom bonded to it. Okay, for this case, Br2 and H2O. So meaning that the atom that going to added is Br and OH. So Br and OH, which one is electrophile? Br is electrophile. So added to the C with greater number of H, and then OH is over here. Okay, so E is actually is bromine in inert solvent. So 2 bromine atom will be added. So Br. Okay, number 2. Suggest alkyl halide suitable reaction condition to produce A. So the alkyl halide, okay, can be Br over here, can be Br over here. Okay, so this is Br over here. Okay, Br over here. So there are 4 possibilities. You just choose suggest N, right? So just only one answer, either one. The most easier one is over here and over here. These 2, I think most of the answer student will write down these 2 answers. This and this. Okay, the reaction condition must potassium hydroxide in ethanol reflux. Okay, 3. Reaction A with cold dilute CaMnO4. This one will form diol. So can be used as confirmatory test. So this is Bayer test. So name this test, Bayer test. Take the observation. Purple color of CaMnO4 is decolorized and brown precipitate is formed, the MnO2. And draw the structure of the product. So simple, the carbon-carbon double bond then becomes single bond from diol. So next question, analyze. Okay, draw structure of product formed from 1-bromopropane react with the following reagent respectively. So 1-bromopropane is haloalkane. So when haloalkane react with ammonia, so ammonia will be substituted over here. And then methanol, so the OCH3 will be substituted over here. And then sodium cyanide, and then the Cn will be substituted over here, so this is the answer. And then the last one, water, so OH will be substituted with the bromine atom from alcohol. Okay, so draw the structure form. Okay, this is the structure form. Or form the structure. Okay, actually you can also show the equation as well. Okay, 3b, draw and name the mechanism for the reaction between 1-bromopropane with sodium cyanide. So this is strong nucleophile, and then this is primary haloalkene. So strong nucleophile, primary haloalkene, means that it will undergo SN2, which is bimolecular nucleophilic substitution reaction. So the strong nucleophile Cn negative attack the halogenated carbon from the rear end, so this is called as backside attack. Okay, and then the Br is the bond between CBr is going to break, and then it's a slow step, break determining step. From the transition state, here bond breaking, and then bond forming, here bond breaking. Must label transition state and the sign of negative, positive, positive. Next is a fast step, the forming of Cn, and then Br negative is formed. So this is the configuration at carbon is inverted as the Cn bond is formed completely and Br negative ion leave. Always, as I explained before, must in three-dimensional structure, and then here standard to left, here standard to right. Okay, next question is related with carboxylic acid. Pentanoic acid can be prepared for 1-butanol F, as shown below. So you have to take note, here is 5 carbon compound, here is 4 carbon compound. So first, substitution is happened, so it will form a haloalkane, and then haloalkane will react with Grignard reagent in dry ether, so it will form the Grignard reagent H, and then the Grignard reagent H, okay, form carboxylic acid. So if from Grignard reagent want to form carboxylic acid, it must react with CO2 and then hydrolyze. So the answer for G is OH substituted by Cl, and then form Grignard reagent with MgCl. Okay, X is carbon dioxide, and then Y is H3O plus or H2O/H plus. Okay, next question asks about give the reagent needed to prepare F from 1-butane. So means 1-butane, okay, from 1-butanol. Step 1, right? Okay, I need to add HBr, but anti-Markovnikov rules, because okay, I want to add the bromine over here. Okay, so must anti-Markovnikov rules. After that, okay, react with sodium hydroxide, aqueous. So substituted, okay, nucleophilic substitution is happened, so must NaOH aqueous, reflux, heat. Okay, 4 suggest an alternative two-step reaction to convert G to pentanoic acid. Besides Grignard reagent, actually we can, by using KCN/H plus reflux, okay, Cn and ion means the Cn nucleophile will be substituted with Cl, and then hydrolyze the Cn, then will form carboxylic acid. Next, question 4. This is the original question. There are 2 parts, part A, part B, and then there are sub-questions for each part. Okay, we go for part A first. Reaction of unsaturated carboxylic acid. Okay, means there is carbon-carbon double bond carboxylic acid with hydrochloric acid yield compound K and L. So mean that here electrophilic addition for Cl over here or Cl over here. That's why form K and L. So, and then draw the structure for Kl, no problem. Which product more acidic? And give your reason. For sure is K, more acidic, because the Cl is nearer to COH. The distance affect the acidity. So K is more acidic than L because the electron withdrawing group chlorine atom is nearer. So the keywords is you must mention Cl is the electron withdrawing group. The second keyword you must mention nearer to carboxyl group. So the electron withdrawing effect from OH bond of the carboxyl group become greater over here. Yeah. Okay, predict the product form when J react with potassium metal. So we react with the COH and then become COO negative K plus like this, and hydrogen gas is released. Okay, part B. Reaction of acetophenone M is shown below. So this is acetophenol, it's a ketone attached with benzene. So now we check what happened. Okay, draw the structure NPQ and give the reagent RST. So we look each one by one. So this is okay, propanol. So propanol H plus. Okay, so nucleophilic addition is happened. Double bond O will become OH, and then the OCH2, CH2, CH3 will be added. Okay, next, how to from benzene become this one? This is alkylation. Alkylation. So R, okay, must with an alkyl group, because alkyl group and must have catalyst. Without catalyst, wrong. Must write down the catalyst as well. Okay, check. Iodine sodium hydroxide. Okay, means there is a methyl carbonyl group over here. If there is a methyl carbonyl over group, then you give the positive test towards iodine form. So it will form CO negative, and this is the light yellow precipitate, CHID, triiodomethane. Okay, then M, B, it will form this one. So what is this? This is from ketone. Okay, reduce become alcohol. So S and T is reducing agent. So we can use, one is lithium aluminum hydride, and then two is H3O plus. Or we can use Na, PH4, and then methanol. Okay, either one, both of them are reducing agent. Okay, 4B3 suggests chemical test to differentiate M from U. M is ketone, and then U is alcohol. So we can use Brady test. Okay, if Brady test, it will form orange or yellow precipitate. And then for alcohol, nothing happened. Or we can test for alcohol by using Lucas test, because this is secondary. Okay, secondary alcohol. If secondary alcohol react with the Lucas reagent, right, Cowley solution is formed within 5 to 10 minutes. But for carbonyl compound, there is no Cowley solution is formed. So as I said before, when I answer the chemical test question, you must tell me what is the test, what is the reagent. Equation 1, observation 1, equation 2, observation 2. Same for here. Okay, you can choose either one. Either you want to test for the carbonyl compound, or you want to test for the alcohol compound. Question 6. So this is the original question. One question, 20 marks. But sure, there's many sub. Okay, 6. Okay, I divide it become 3 parts. Acid catalyst dehydration of 2-pentanol. Give compound B and W. So this is elimination. Okay, and then give the carbon-carbon double bond, alkene. Okay, so I transform this to the equation. So this is 2-pentanol with concentrated H2SO4 heat, and then form 2 alkene compound. This one is the major product because follows Sage's rules. And then some more based on the question, compound we inhibit geometrical isomerism. You check. Okay, this one can form cis trans. Okay, this is cis, and then this is trans. But for this one, okay, we check for the C double bond C. This contain two same atoms, so cannot form geometrical isomer. Okay. Ozonolysis of compound V produce Z and A. So you try to write down this equation. Okay, ozonolysis, the bond is breaking, and then form double bond O. It will form the pentana. Okay, here will form the etana. Okay. So this is Z and AA. Okay, draw the structure VW, done. Identify the major product, done. And explain your answer. Okay, as I say, this is due to Sage's rules. Okay, we check. Is major product according to Sage's rules. The major product is alkene with a greater number of alkyl group bonded to the carbon-carbon double bond in an elimination reaction. So here, 1 alkyl group, 2 alkyl group. For this one, only 1 alkyl group. That's why V is the major product. And then draw geometrical isomer of V, done. must label, this is cis isomer, this is trans isomer. If you able give the name, then it's better. So this is 1, 2, okay, so this is cis 2-pentane, this one is trans 2-pentane. Okay, next. Okay, for the second part, the question requests write the mechanism for the dehydration of 2-pentanol, so elimination reaction. Draw the structure Z and AA. Okay, we have drawn the structure at the early part. Write reaction equation for the ozonolysis of it, you're done already. Okay, so now we write the mechanism. So first, okay, what is the name of this reaction? Dehydration of 2-pentanol or dehydration of alcohol. If the question, what is the type of the reaction, then it's elimination. So step 1, okay, the name is protonation of alcohol. Okay, step 1, protonation of alcohol. So the addition of H3O plus ion from acid to the hydroxide group. Okay, so here, okay, taking the H atom and then become a protonated alcohol. Okay, something missing over here. Have to add the H, have the H plus of positive charge for the oxygen atom, and then from the water. And then step 2, formation of carbocation. So the CO bond is broken. Okay, so water molecule is eliminated to form the secondary carbocation. Then step 3, formation of alkene. Now the CH bond is broken and the hydrogen ion is eliminated from the secondary carbocation. So a new pi bond is formed between the CC atom to form alkene. So the red one actually is the major product according to Sejav rule. And the green one, I can take the H, okay, from here and then form the minor product. Okay, what Sejav say? Okay, carbon-carbon double bond with the greater number of alkyl. So this one alkyl group, 2 alkyl group. But for this case, only 1 alkyl group. So this is minor, this is major. Okay, next, by using a suitable alkyl halide and ZZ or AA, show how 2-pentanol can be synthesized with a Grignard reagent. So just now, okay, 2-pentanol means 5-carbon compound. Okay, my ZZ is 3-carbon compound. This is propana, and then so I need a 2-carbon alkyl halide. So if 2 alkyl halide, I try this one, ethane chloride. So react with propana, then okay, I form the Grignard reagent. Okay, actually I have to form the Grignard reagent first. After I form the Grignard reagent, right, okay, so attach to here and then hydrolyze. Okay, it will become 1, 2, 3, 3-pentanol. So I cannot use propana. Okay, let's check again if I'm using ethana. Okay, ethana. Okay, my ethana form the Grignard reagent first. Okay, magnesium hydride form the Grignard reagent, and then the Grignard reagent react with this aldehyde. So aldehyde means ethana, and then we check. So H remain. Okay, so hydrolyze it. Okay, yes, it will form 2-pentanol. That's why the suitable alkyl halide is this one, which is propane, 1-chloropropane. Okay, next. Question 7a. There are 2 parts. Part A 10 marks, part B 10 marks. Okay, let's go through together. So part A, compound BB is formed from reaction between benzene and ethane chloride. So I transform these sentences into equation. Okay, so this is BB in the presence of aluminium chloride. Then oxidation of BB, okay, with KMnO4/H plus heat, and then from CC benzoic acid. Then benzoic acid, okay, CC with ethanol. So this is praise of sulfuric acid. So esterification happen, ester is formed. So and then produce DD. Okay, DD is over here. Wrong labeling. DD suppose is here. And then in the type of reaction, so the type of reaction is Pietrokrov oscillation that convert benzene to BB. Suggest a structure for BBCCDD. Okay, done already. BBCCDD is over here. And then write the reaction equation. Yes, I have write all already. But the question just requests from formation of BB, so it's this one. And then the formation of DD is this one. Okay, next write the mechanism for the formation of BB. The formation of BB actually is mechanism of Pietrokrov alkylation of benzene. So the type of reaction is electrophilic aromatic substitution. So step 1, formation of electrophiles. So the haloalkene, so this is the haloalkene, is polarized by the catalyst to form an electrophile. So next, electrophile attack the pi bond, pi electron of the benzene ring, and a certain intermediate uranium ion is formed. Then step 3, deprotonation means loss of proton or H plus occur to retain the aromaticity of benzene ring. Okay, next. So an alkyl bromide EE react with ethanol to give FF. So EE ethanol to give FF. Okay, since I'm not sure the EE yet, and then I cannot draw the FF, but I can draw first. And then whereas compound, okay, this compound is formed when EE is treated with the nucleophile. I can draw first. Dehydrohalogenation of EE, so dehydrohalogenation of EE produce GG, which obeys Sage's rule. Sage's rule is special for alkene, so I know this is alkene. So deduce the structure of EE, FF, GG, and nucleophile. So EE, FF, GG, where's my GG? Okay, here is my GG and the nucleophile. So this is the nucleophile. And write the reaction equation for all reaction involved. The major hints of this question is over here, the ester. So we must know, okay, based on this ester, we can try to break the bond over here or break the bond over here. If we break the bond over here, right, then this is carboxylic acid, means ethanol acid. And then here is 1, 2, 3, 4 butanol. Okay, but carboxylic acid actually not a nucleophile, and then this is must be alcohol. But what we want is from is a haloalkene compound. So we have to try over here. If we break over here, okay, then this is a butane. So butane, yes, we can add Cl and then form a alkyl bromide. Oh, sorry, suppose it's Br, not Cl, Br. And then here is the alkoxide part. So this is ethoxide. So this is a nucleophile. So based on this ester compound, we can deduce the EE and the nucleophile. Next, after we success get the alkyl bromide, and then we check alkyl bromide react with ethanol. Actually, it's nucleophilic substitution. So the OCH2 CH3 will be substituted over here, replace the Br. So this is FF. Okay, and then next, so EE, dehydrogenation of EE. So dehydrogenation, we need to use the potassium hydroxide in ethanol and then form the alkene. So I can form at over here or over here. It's formed over here, this is the product. It's formed over here, this is the product. Among these two ways, which one is the major product? Definitely this one, because there are two alkyl groups here, only one alkyl group. So this is GG. So this is the way to deduce the question, to analyze the question. So we check this is the structure for EE, alkyl bromide, FF, nucleophile, ethoxide, and the alkene GG. So we have to draw the you have to write the equation for the formation of each reaction. So alkyl bromide react with the ethanol from FF, and then alkyl bromide react with the nucleophile from the ester compound, and then alkyl bromide react with undergo dehydrohalogenation, elimination reaction to form the alkene GG. So if we check here, right, only 1, 2, 3, 4, 5, 6, 7 points. So how about another 3 marks? So actually we need to explain how are we deduce the structure. So first, FF is an ether because alkyl alkyl bromide EE undergoes nucleophilic substitution reaction. Okay, so this one is an ether. Okay, the Br atom is substituted with, so this is the ethoxide group. So this what I explained just now, you have to rewrite again in sentences and then explain in proper way. And then this treatment of EE with nucleophile produce an ester, so the nucleophile is ethanoate ion, which is CH3COO negative ion. Next, GG is an alkene. Why? Because hydrohalogenation of alkyl bromide involve elimination of hydrogen and halogen atom. So the last one, GG is a highly substituted alkene. That's why contain more number of alkyl groups. So this compound follows Sage's rules. Yes, this is the last question. Okay, this question, there are 3 parts. So this is for amino acid, and polymer. By using amine of your choice, explain the basicity of primary aliphatic amine, secondary aliphatic amine, and aromatic amine. So suitable example, so primary amine we try to use 1-butane amine, and then secondary aliphatic we use N-methylpropane amine. So because the number of carbon for both atoms is the same, 4 carbon, 4 carbon. And then tertiary aliphatic amine we try to use N-dimethyl-ethane amine, so 4 carbon compound as well. And then the most general aromatic amine is aniline, so this is the primary aromatic amine. Okay, next, there are 2 factors that affect the basicity. One is inductive effect, another one is resonance effect. So for N-methylpropane amine is a secondary amine, is more basic than 1-butane amine, which is a primary amine. Why? Because N-methylpropane contains more alkyl group attached to the amino group compared to 1-butane amine. And then why alkyl group has greater effect in basic? Because alkyl group are electron withdrawing group that increase the electron density on the nitrogen atom, the amino group. So the nitrogen atom of N-methylpropane amine has a higher ability to accept a proton. So when it says higher the ability to accept proton, right, meaning that it can form hydroxide ion. So it is more basic than 1-butane amine. When we compare the basicity by using inductive effect, is referred to the alkyl group, which is an electron donating group. Okay, resonance effect we normally will compare with aromatic compounds. So aniline, a primary aromatic amine, is less basic than 1-butane amine, N-methylpropane amine, and N-dimethyl-ethane amine, a tertiary aliphatic amine. So meaning that among all of these, right, aniline is the weakest base. Okay, the lone pair electron or nitrogen atom of aniline is delocalized into the benzene ring and make the aniline to form resonance stabilized structure. So this makes the nitrogen atom of aniline has lower ability to accept a proton. Means it cannot release hydroxide. So and it is the weakest base compared to 1-butane amine, N-methylpropane amine, and N-dimethyl-ethane amine. So this, right, one question I want to ask. If we compare the primary aliphatic, secondary aliphatic, and tertiary aliphatic, which one is the strongest base? So the answer is secondary aliphatic amine, followed by primary aliphatic amine. And then tertiary aliphatic amine is the weakest base. Why? This is because, right, the tertiary amine contains 3 alkyl groups. So the 3 alkyl groups decrease the availability of lone pair electron or nitrogen atom to accept proton. So this kind of situation we call it as steric inhibition of solvation. So this effect diminish the ability of solvent to stabilize the alkyl ammonium ion. Okay, so let's check for the okay, p-phenol, an orange dye and its structure is shown below. So show a synthetic pathway for the preparation of this compound by using phenol. Okay, started from aniline, okay, by using nitrous acid at 0 to 5 degrees Celsius. Okay, because this condition is more stable to form the benzene diazonium salt. Okay, then the benzene diazonium salt will react with phenol to produce the 4-phenyl diazenyl phenol. So actually this is like condensation process. So next, this question is related with amino acid. So given 2 amino ethanoic acid and 2 amino propanoic acid are amino acid. So draw all possible structure. So this is a structure for 2 amino ethanoic acid. This is a structure for 2 amino propanoic acid. And then draw all possible dipeptide arising from these 2 amino indicate the peptide bond. So there are 4 possibilities. So I label this one is A, this one is B, so easier to understand. So this is the peptide bond that arises combined with, is the reaction between 2 amino acid propanoic acid with 2 amino propanoic acid. So that's why peptide bond is from over here, C double bond O and H. So here is the peptide bond. And then this is a peptide bond that arises from AB. A and then B. So this is the peptide bond arises from BA. So B come first, okay, so the OH and then followed by the N over here. And then this is the peptide bond that arises from AA. So AA, so C double bond O, and then combine again over here, and NH, CH2, C double bond O. So clear? When the question asks about the possible peptide bond, if there are 2 amino acids given, so there are 4 possibilities. Remember, it's BB, BA, AB, or AA. So question is related with polymer. By using appropriate polymer, explain homopolymer and copolymer. Of course, you need to give the definition of homopolymer. Polymer formed from a single type, so normally is in addition polymerization. Okay. Copolymer is a polymer formed from the joint 2 different types of monomer, normally from condensation polymerization. The example given is Dialon 66. This polymer is joined from 1,6-hexene diamine with hexene diode acid. Okay, that's all for this video. Hope you all enjoy, and remember, practice make perfect. Bye.